Why can't I make that subtraction right now? Why isn't it 4 root 10?
Because the number inside of the things aren't the same.
Excellent. Now let's make that a math sentence. The radicands are not the same. If they are to add or subtract, the radicands must be the same, which means I must change what the radicands look like. How do I change what the radicands look like? You just did it 3 times. You simplify, right? What's this? 9 times 2. Exactly correct. What's this? 4 times 2. Exactly correct. Take out the roots. What's the root of 9? 3. What do you do with the 3 and the 4? Excellent. 12 root 2 minus, what's square root of 4? 2. So what comes out? Excellent. 12 root 2 minus 2 root 2. What do I get? 10 root 2. Yeah? Everybody? If you have a body, you got that answer? Excellent. 2 times 49. 2 times 36. 2 times 25. So what does it become? 7 root 2 minus 6 root 2 minus 5 root 2. And what do I get? Negative 4 root 2. Nicely done. 128 and 250. Well, that's 64 times 2, and that's 125 times 2. Cube root of 64 is what? 4. So that's 4 cube root 2 plus 5 cube root 2, which is 9 cube root 2. Yeah? And finally, 500 is what? 125 times 4. 32 is 8 times 4. Cube root of 125 is 5. So that's 35 cube root 4 minus cube root of 8 is 2. 6 cube root 4. 29 cube root 4. Yeah? Yeah. Now, whoo! What'd you have to use to do this? Not trig. What do we have to use, Harmon? Pythagoras. The root of 2 squared plus the root of 8 squared has to equal a squared plus b squared has to equal c squared, has to equal x squared, yes? Right? Okay. So, can I add those right now? No. But I can add them. Because what is the square root of 2 squared? 2. What is the square root of 8 squared? 8. 2 plus 8 had to equal x squared. So 10 had to equal x squared. So what did x equal? No, square root of 10. Yeah, but that's not what you said.
That's what I have written down.
Excellent. Can you simplify that? Yay or nay? Nay, because that is 2 times 5. Are there any pairs there? No. So nay, we cannot simplify. Get it? Nay. I made a horsey noise because horsies say nay. Fine. Yes, they do.
No, I have 2 of them. No, I don't.
Lots of people have horses.
My mom grew up on a farm and she did lots of horse riding.
All right. My daughter wants a horse. She says she wants a horse more than she wants a car. Yeah.
We have like a
Then we said to her, Beth, you don't even walk the dog. What makes you think you would take care of a horse? And she said, walking the dog's a chore. Riding a horse isn't. No, riding a horse isn't. But putting on the saddle, scooping up its crap, brushing it, cleaning it, digging the gunk out of its hooves.
Maybe she just wants horse riding lessons.
She does. We've taken her for horse riding lessons. That's why she thinks she wants a horse. Because when you go to a lesson, all you do is...
You have to go to a lesson and ask if she can help.
No, she does have to help with that, but it's still only a lesson. Once you have to do something all the time, once you have to do something, it is no longer fun. I love teaching, but it's my job. Do you not think, if they stopped paying me, do you think I would be here 6 hours a day?
No.
Absolutely not. Do you think if nobody paid me, I would go surf for 6 hours a day? Absolutely. If surfing became my job, though, and I had to surf every single day for my job, do you think I would enjoy it as much as I do now? No. Same thing with cooking. People always say to me, Myers, you should open a restaurant. No, because then cooking will become a job. I love to cook, but I don't love my job.
Well, shouldn't you do a job that you love?
You should do a job you love, but that is only so you don't end up throwing yourself off a building.
Wow. We went from 0 to 100 real quick.
Regardless of what your job is, if you would ever if they stopped paying you for your job and you stopped going, then you are not doing something you love.
So deep now.
Understand?
Wait, so did you say that if they stop paying you to teach, you'd still teach?
No, of course I wouldn't. I love teaching. It's my favorite thing in the world that I could ever imagine doing for a job, but it's still a job, which means I have to be here regardless of how I feel about it that day. If I don't feel like going surfing and I'm on a beach, I don't surf because it's not my job. If I don't feel like teaching because something bad's happened or whatever, I still got to come and teach. So even though I love it, if you didn't pay me to be here, I would not be here. I would be doing something that I would want to do. That being said, I've been doing this every day. I've been coming to school every day since September 6th, 1980. That's how much I love school. Kindergarten to grade 12, all university, and I've been teaching every year since. And I'm about to turn 43.
How long do you think you'll still be
Until my daughter graduates high school. She is in grade 6 right now. The day after my daughter graduates high school, the fire sale begins, and every single thing I own gets sold. I put a backpack on my back, and I fly to Ecuador. I hope.
So you just,
If I like Ecuador enough.
so you just let her like stay here on her own.
She's finished high school. What more can I do for her?
On to university.
Excuse me?
Oh yeah, right. University costs. Sorry. Never mind.
So welcome to Join Me in Ecuador. There's universities in Quito.
Does she speak the language?
That's her problem. She wants to be a marine biologist. I'm going to send her to the Caribbean on a 2-week marine biology camp. It's going to cost me a lot of money, but I'm going to send her anyway because I love her to death. And she can make her mind up then. Because even though she's at summer camp, she will still have to get up every day and perform marine biology chores, which will make it a job. And she will see if she enjoys it. Because that is a good investment in my daughter's future.
That's actually really smart.
My son's a deadbeat, so it doesn't matter. No, he's not. I love my boy. They just auditioned for a new Cartoon Network thing. On Halloween of this year, you guys may see, well, you'll hear my kids doing the voices for some monster surf beach thing. My younger kids? Yes, my kids are younger than me, Harmon. It's kind of impossible for your kids to not be younger than you. Although there was an episode of Star Trek, they never explained how it happened, but everybody aged in reverse. So the babies were adult-sized, and then you got older, but you aged in reverse, which kind of makes it difficult to explain how an 8-year-old body could have a baby that was a grown-up person. They didn't explain that part. You just had to believe that that's the way that civilization was. It was a cool Star Trek. I mean, every Star Trek's cool. Shut it. Star Trek's awesome. You can have that opinion. It's just wrong. You can have that opinion too. It's just wrong. Yes, it is. I am validating your opinion. I am allowing you to have it. You're just wrong. All right. Where are we right now? Oh, we're done everything. Holy crap. We're moving on to page 129. Dun, dun, dun. Now, notice right there, we skipped over quiz 2. So what does that mean? Quiz very soon. Is a quiz anything to be worried about? No. Do you still stress about them? I don't know why. I cannot understand it. Here is a glass of Coca-Cola. It does not affect your math grade at all. Would you like to drink it in math class? Oh, yes, I'd like it very much. Thank you. Yum. Here is a quiz. It does not affect your math grade in math at all. Would you like to write it in math class? Oh, no! No. They have the exact same effect on your math grade. Drinking a glass of Coke or writing that quiz. And yet, you're all still... Because I called it a quiz. I've tried that, Lena. I have tried calling quizzes by different names. It doesn't help. I have said, you're writing a Snicklefritz tomorrow. You're writing a Kaboobly Heinz tomorrow. You're writing a Grapple Grommet tomorrow, and kids still stress. Sometimes I give them a piece of paper that has no title on the top, and they do all the work, and they get it perfectly right. The next day, I'll give them the exact same questions, but I'll write quiz on the top, and they'll fail. The exact same piece of paper, but the word quiz, and all of a sudden, I can't write tests. I just freeze up when it's a test. Oh, really? Because those 7 questions you did yesterday, like that, when there was no title on it. But this is a test. Oh, really? So you tell me. Now, I know it's because that you people have undeveloped brains. Your brains don't finish developing till you're 25. I know that. I researched this stuff. I get it. Really. Really. 25.
But isn't it also like
And
we're not
it's also
supposed to be
because...
waking up, like, technically according to the teenage brain, you shouldn't wake up for like 9 or something.
No, that's horse crap. You should get more sleep than you get, but that is your problem, not mine. It has to do with your circadian rhythms.
Because weren't there multiple studies that shown that the school starts at 9 rather than 8, the overall student...
No, because you know what will happen? People will still be late. People will still sleep in. Because what happens every second Thursday when school does start at 9?
Well, but it's only every second. No, like the study has shown that compared to the school that has starts at 9 o'clock versus the school that starts at 8 o'clock, that the marks went higher for the school that start at 9.
Mm-hmm.
Because it's a little more weight.
You could make that conclusion, but there's many other conclusions you could make too. Correlation doesn't prove causation.
So what would you think? Why the students were much better?
Well, one of the reasons is all of you complain constantly about how early school starts. So if we moved it to 9, you would all think, oh, I've won. We've moved it to 9. So for a year or two, yes, it might make a difference. But sooner or later, because you are really not punished for being late and you're really not punished for not coming to class, you are because you're an international student, sooner or later you would start taking advantage of the fact that it starts at 9. You'd start rolling in at 9:05. And then somebody would say, well, maybe we should move school to 10. And then for a year, it would work. And then kids would start showing up late, skipping. Well, maybe we should move school to 11.
No, but isn't that like most people can't isn't that like
Go to sleep. When did you go to bed last night?
9 o'clock?
Great. That's good.
I was like,
That's
oh,
the
okay.
problem.
Well, I was
11. When'd you go to bed? 12:30. When'd you... Oh, you don't count, Green. Jalen, when'd you go to bed?
Like 1:30 in the morning.
He can't even tell time! 1.5 isn't a time! That's why school start times don't matter.
School time starts. School times don't matter.
That's why it doesn't matter. Because you people will stay up late as long as you want. What were you up doing late? Were you reading? Were you expanding your knowledge? No, I was watching Epic Fails of 2018, and then I played a couple of rounds of Call of Duty 12.
Fortnite.
Doesn't matter.
so if you'd stay up late reading, would that make it better then though?
It would at least be a useful use of your time.
I was doing homework.
You were not doing homework till 12:30 at
I
night.
got home at 8. I had.
You had 4.5 hours of homework.
Yeah, 'cause
I gave you 4 questions.
I didn't do my French because I wasn't here all weekend, and then I didn't get any time to do anything. So I was doing French, and I was doing.
Didn't you go to the island this weekend?
Yeah.
Island's a 2-hour ferry ride each way.
Yeah.
There's 4 hours. What'd you do on the ferry? Oh, I walked around. I played some video games. I looked out the window. I went in and out of the gift shop with stuff in my pocket so it'd set off the alarm. I've ridden ferries, Harmon.
Yeah.
There's desks and study carrels.
Okay, I was thinking.
You see these notes here? For your entire class, for the whole year, I made in 1 ferry ride from Nanaimo. Yeah. No, I'm not going for applause, Harmon. I'm going for use your time wisely. And you know why I did it on the ferry? So when I got home at 10 o'clock, I'd go sleep. Not stay up until 12:30 doing it. Just saying. Now, part of that is because my brain is finished developing. I can see cause and effect. You guys can't. I gotta play Fortnite until 5 in the morning. Oh my God, school's in 2 hours. But Fortnite was fun. Here, do these 3 questions. It's called a quiz. I can't. I don't know how. I have quiz anxiety.
But it's like we do know the cause and effect, but we just evaluate.
You choose to ignore it.
We just evaluate.
You ignore it.
I like to say we evaluate it.
You ignore it. Now, let's do some math. Green, you totally count. You don't not count. But for the purposes of that argument, I needed somebody from North America. Specifically Canada or the United States. Even a Mexico kid wouldn't have worked. All right. A British person would have worked. Or an Australian person. Because Britain and Australia have similar teenagers to North America.
But they have stricter schools, though. Like they actually get in a lot of trouble
All right.
if you come late.
Multiplying radicals can only occur if both radicals have the same what, do you think? Just, let's write it out. Remember, this is a radical. X root A. Right? If I'm going to multiply radicals, what do you think? We know when they add, they have to have the same radicand and the same index. What do you think they need when we're multiplying? Just the same index. Because, of course, you all remember from your exponents practice. No, you don't remember that yet. You know that the exponent is related to radicals, yes? So, if we're going to multiply, they have to have the same index. Because the cube root of x is different than the square root of x. I just need to check something. Really hard exponent practice. Yep, okay. I know where we are. Yeah, okay. All right, everybody cool? But once we have them with the same index, it's really super easy. Remember, the example I've been using for this is coefficients and variables, right? So if I had 2x times 3x squared, what would your answer be? 6x cubed. Why? What did you do to get that?
Multiply 2 and 3, and then because the variables have
You multiplied the coefficients, and then you multiplied the variables, right? Okay. So in radicals, as long as they have the same index, you follow the same pattern. Okay? So if I have b x root a times c x root d, your answer is, just like over here, what would it be? Do you think? Luke? BC x root AD. Does everybody understand? So we'll start with a nice easy one in the first one. What is the B and the C? 7 and 5. So multiply them. What's negative 7 times 5? Negative 35. What are the B and the C? I mean the A and the D. So that is root 24. Right? Now, just to make sure, how did I get that answer? Negative 7 times 5, bracket, root 3 times 8. Everybody cool? Okay, now, would you ever leave that like that? You have to simplify it. Okay, and where would you simplify? You would simplify at 24, which is 4 times 6, correct? Why did I use 4 and 6? 4 has a square root. What is it, Jalem? 2, so where does that 2 go? Out there. And what does it do with the 35? Negative 70 root 6. Now I want you to notice something. What could I have done right here? If I'm working this out this way and I don't see 35 and 24 right away, what could I do right there? Could I simplify there, where the numbers are smaller? 4 times 2, bring out a 2. And that left a 2 in there with the 3. Does everybody see that as well? Okay, so let's look at B. What's different in B? What's different between B to A? There's no coefficient out front, but there is a coefficient out front. What is it? 1. So this is what? If I was going to write it out fully, what would I write? What would be the coefficients? What would be the coefficients? I want you to tell me what would be the coefficients if I wrote it out fully like I did right over here. It would be 1 times 3, and what would be the radicand? 8 times 2, right? Which would be 3 root 16. Would we stop there? Of course not, because what is the root of 16? 4. So what would come out? 4, and what's already out there? So what do I get? 12. Anything left in the radicand? No, so it's done. Everybody good? Everyone good? Okay, you do the next one. Do C. Did everybody get that for C? Going once. Going twice. Going thrice. All right. D is really easy. Now I'm going to do something here. You'll notice what was my first step every time? You guys cool? Marley, you cool? What'd you forget to do? Okay. All right. You'll notice in all of these I've written them out long ways first, right? I'm doing that for a teaching perspective, yes? Okay, so I'm going to write this out long ways again, but then we're going to talk about it. So this would be 3 times 1 root what? What's under the what's the radicand? 3 times 3, right? Which becomes 3 root 9. 9's got a root, so what comes out? 3. So this answer is indeed 9. Everybody with me? Okay, now I want to talk about this case right here, which is this case right here, which is root 3 times root 3. Now, since you people are in pre-diploma math, you are able to make this connection very, very quickly. Obviously, the square root of 3 squared must be 3, right? A lot of people have problems with that. They're like, what? So I like to make sure I show them that is the same as root 3 times 3. There is my group of 2, correct? So out it comes, and I get the answer. It's 3. Which leads us to this. The square root of x squared is what? X. No matter what's under there. Okay? Whatever your radicand is, if you square it, the answer is the radicand. Does everybody understand that? So when you're doing higher level math, if you need to get rid of a radical that you don't like, all you do is square it and it goes away. Okay? Okay. What's different in E?
We're going to have to foil.
Not FOIL, we're going to have to distribute, right? Stuff we already know, right? If this was 5x bracket 3y plus 4z minus q, what would we do? We'd distribute. The first one would be 15xy, correct? The second one would be 20xz, correct? And the third one would be 5xq, right? So what do we do here? Same thing. That's how math works. Our first one, we pretend that none of this is even here. You know how to do that. We've just done it 4 times, correct? What is it? You don't have to write the long way anymore. I'm trusting you. 15 root 16, correct? Okay? What's the next one? It would be this. Plus what? 10 root 24. Okay? And then do the last one. Minus 5 root 40. Now this takes us back to yesterday, doesn't it? I can't put those together right now, can I? Why? They don't have the same radicants. They are not like terms. But they're also simplifiable, yes? So I make sure I simplify them because maybe we can put them together. What's square root of 16? So what comes out? 4. What's there? 60. 24 is 4 times 6, yeah? What comes out? 2. What was already there? 10, so that's 20 root 6, yes? What's 40? 4 times 10, yeah? What comes out? 2. And there's already a 5 there, so it's 10 root 10. Can I put them together? Can I put them together?
Yes.
Where?
Where is that? Oh, you know.
So that guy's done. Cool? All right. Is everybody good to there? All right. Now listen. If you've been memorizing steps and not thinking about what we're actually doing, then the thing you're going to do with F is this. You're going to go cube root of 16 times 54, which is the cubed root of 864. How many of you want to factor that? I don't. So what do? Simplify first. You can simplify here and here, or you can simplify here and here. Does it matter which? No. Let me show you what I mean. In red, I will simplify here. Since it's cube root, I'm going to use 8 and 2 and 27 and 2. Is everybody happy with that? Okay. So what comes out? Cube root of 8 is what? 2. So I'm going to have 2 cube root 2. Agreed? What's cube root of 27? 3. So 3 is going to come out, and I'm going to have 3 cube root 2. Yes? Okay. Now, what's 2 times 3? Cube root 2 times 2. 4. And I can't simplify that anymore. Now, I know I just said up here, if you square the root, you get the radicand. So why is this not 2? Because it would have to have been cubed. Does everybody understand that? So that's the answer. Now, the other option I gave you was you could have done this. Cube root 16 times 54. You can simplify right here, right? This is 8 times 2. This is 27 times 2. Cube root of 8, 2. Cube root of 27, 3. And what did I leave under there? The 2 and the 2. 3 times 2, 6. Cube root 4. Do I care which way you do this? No. What's the point of this question? That you do not try to deal with that. Because why would you try to factor something that gigantic when you can factor 16 and 54? Does everybody understand? Now, the next thing I would like to point out is how many radicals now have we simplified? Buckets, right? Have we given an irrational answer even once? No. That's the whole point of what we are doing. You are no longer going to be using the square root approximation of that very often. Okay? Where you will use it is in physics, right? Because you need to get a speed or a velocity. You're not going to say, well, that the rocket was traveling at the root of 864 kilometers per hour. You wouldn't say that. You would give the approximation. Understand? But in math class, we go for exactitude. Everybody with me?
How do we calculate exactitude with the radicals?
This is what you do. You can't do any better. This is getting exact answers. We had this discussion when we were talking about trig, right? We didn't use the decimals. Everybody cool? All right. So look at the next one. What are you going to do? Because you know that is 15 root 1764 or some crap like that, right? I don't want to factor that, so what do? Simplify first. Okay? Your choice. I like to simplify here. 4 times 7, 9 times 7. Square root of 4 is what? 2. What goes out? 2. What's already there? So what do I get? 10 root 7. What's square root of 9? 3. So what goes out? 3. What's already there? 3. So what do? 9 root 7. Now, what's 10 times 9? 90. Technically, what's root 7 times root 7? Well, technically it's root 49, right? But we know the shortcut. We know root 7 times root 7 is 7. So this is really 90 times 7, which is what? 630. Gouda? Grapes. Hola. H. Now what do we got to do? Say it, Luke. Foil. Remember, I don't particularly like foil, that word, because really what are we doing? Double distribution, right? So what do I have here really? I got 2 root 8 times those, and I got 3 root 7 times those. Correct? So in blue, I've got 4 root 24 minus 6 root 16, correct? Everyone's happy with that? Okay. And what are my red ones? Plus 6 root 21 minus 9 root 14. Now, should I check? Can any of that simplify? If yes, where? Where will that simplify? He asked. Where? 4 root 24, because that's 4 times 6. That's 8 root 6. Minus. Does that one simplify? What? Square root of 16 is? So what comes out? Negative 24 plus 21 simplify? Why not? 24 simplified. 21's in the 20s. Why doesn't it simplify? Because it's 7 and 3 and there's no pair. Nice job. What about 14? Nope. 7 and 2 and no pair. Now, you can write that in a different way, but do I care? No, I don't care about order. Get me the answers. Is everybody good? All right. Turn the page over. Let's do some practice. I'm going to write a couple easy ones. You're going to write it. You're going to practice them. Then I'm going to put a couple of harder ones. You guys try those 5 for now. That's your practice work for now. And then we'll see where that leaves us. It's 9:10. Make sure you try to copy that down, because we may not get to it today. You may work together. You need not. Work by yourselves. Yo.
When does term 3 end? Or has it already ended?
We don't have terms.
No, just because like MJ does that in her.
Well, then why are you asking me when MJ would end her term? She's MJ. I'm me. Tell you what, I'll check right now. I got nothing.
But are we already over half of the semester?
Are we?
I don't know.
The semester goes to the middle of June. We started in February. It's 20 weeks long. So 4 weeks in February, 2 weeks in March is 6. We're coming up on our second week of April. Yeah, we're rapidly approaching halfway. It is 9:14. Are people ready for me to go over some of these, or are you still working? Or do we want to just go into the end of the day with this? Talk about it tomorrow. Okay, you have a quiz tomorrow. Quiz tomorrow is on simplifying, adding, and subtracting radicals. Right, you're going to that thing tomorrow. You have a quiz Thursday on simplifying, adding, and subtracting radicals. Because we're going to that thing tomorrow. If you didn't bring a permission slip, you're not going to that thing tomorrow. Me, just like Mr. Grell said.
What would you do if you didn't turn it in?
I will leave a giant worksheet for you.
Where were you going to do it?
It's not my problem. If you would rather do a giant worksheet than get an hour off and a bus ride down to Trade X, then don't bring me a permission slip. If you want the day, 2 hours off and a bus ride and to hang out with your friends, bring me a permission slip. Do so.
Bring it tomorrow, right?
Yep.